Hello and welcome to this film, which is all about ionic compounds. It follows on from the film about ionic bonding, where we looked at what ionic bonding actually is. Here we're going to have a look at what substances will form ionic compounds and how we can show ions forming from their elements using simple diagrams called electron dot diagrams. Right, so how do we know if something is ionic? Well, we should know this already. It's a combination of a metal and a non-metal, like magnesium iodide. Okay, we've got a metal and a non-metal. Not like phosphorus pentoxide. Okay, here we've got two non-metals combined, they won't be ionic. Another little clue is if it's got this kind of di, tri, tetra, pent thing in its name, then it's not an ionic substance, because ionic substances don't involve these prefixes that tell us how many of something there is. The exception, I suppose, is anything with ammonium in, because ammonium ions aren't metal, but this substance is ionic in spite of the fact it hasn't got metals in, but ammonium ions are positive ions. Okay, so assuming that we can decide that something is ionic, if we're asked to draw an electron dot diagram, that's the first step really, because there are different types of electron dot diagrams for different types of bonding. So if we're going to draw an electron dot diagram, if we're going to be confident we know how to do it in a test, it's vital that when we look at the name of a substance we can decide what type of bonding there is. Now if we're showing ions forming, what we want to do is show the atom with just its outer shell electrons either gaining or losing electrons to form a compound. So here we've got sodium combining with fluorine. Oops, let me just start those again. Sodium atoms, which have one electron in their outer shell, are going to lose electrons and form sodium ions. Now, ions will always have square brackets around them. Metal ions will always have empty outer shells because they lose their electrons. Okay? If this sodium atom was to combine with a fluorine atom, which has 7 electrons in its outer shell, I'm drawing my electrons as crosses, but they could easily be drawn as dots, which is what lots of people do. Fluorine is going to gain sodium's electron, and it's going to end up with a full outer shell. So my non-metal is always going to have a full outer shell of electrons. Its charge has to be shown outside of the square brackets. It's gained 1 electron, so it's a negative ion. This should be really simple. It should be something that you can already do by the time you start the IB course. Okay, but if you're asked to draw an electron dot diagram for an ionic substance, make sure you know this is the sort of thing they're talking about. As usual, if you want to show your electron pairs as lines, then you can do that. Okay, so an electron pair can just as well be drawn as a pair of dots or a pair of crosses, or a straight line in an electron dot diagram will also represent a pair of electrons. Okay, well, let's just do another one for magnesium sulfide. Okay, I'm going to start with magnesium, which has 2 electrons in its outer shell, so I'm going to draw that as a pair. That's going to lose 2 electrons, so it's going to become, well, it's a metal ion, so it's going to have just an empty shell, 2 plus charge. Sulfur is in group 6, so it's got 6 electrons in its outer shell. It's going to gain 2 as it becomes a sulfide ion. And so, as usual, our non-metal ion has a full outer shell and whatever charge we need. Now, we're going to look later, once we know how to draw covalent electron dot diagrams, how to combine those to show electron dot diagrams for ionic compounds that have covalent bonds in them. But for now, we're just dealing with the very simple ones where atoms are gaining or losing electrons to become ionic compounds. Hopefully it all makes sense. Hopefully it's something that you find quite easy. Okay, but if you've got any questions or comments, then please feel free to post them on YouTube or to come and ask me for some help.